What do you get? Okay, see that? Can you see that left and right we are correct? You don't need to check it using. Alright, so please, let's move. Yes, if your A dot A plus B and your B dot A plus B is not equal to 0, that means you are wrong. So, did you get 0? So once you do it and you are not getting 0 with 2, you are wrong. So what is telling us is that we are not naturally. What is telling us is that naturally we are not supposed to dot A or dot a cross product. That we are not supposed to dot a cross product. You know that this is a cross product, is it not? So once we are using A, that one given to us that we use for A or B to get this. Once we are trying to dot it, it will always give us 0. That is a 0 vector. It shows that there is nothing there. We are not supposed to dot it at the first place. So that's the proof. Once you do your own and it's giving you a value, you are wrong. Alright, next one. Somebody was saying, what about this side? See, you will do this one for me at home. No crosswalk, so that we can do math. So you do 2A, 3B, 2A. Now let's say 8A, 4B, 3C, 4C. Under I, J, and K. You said something like this? Yes. Okay, I'm not done it. So what it means is simply telling you, it's just telling you that everything here falls on a C. Everything is supposed to have A and not C. And then I have B. What this is telling you is essentially saying, if I have vector A now, this is essentially saying I go here, I have 2I plus 8J, then plus 3K. Are you seeing it? Are you seeing it? Yes. So what it means is that all these things are values of A. So on the X, the Y, and the Z, that is I, J, K. Why everything that has B is the same as saying vector. Okay, I'm going to present this to make it easier. So, okay. I see it. Yes. But when you see it like this now, you might run mad. You start feeling like, which one is this one again? So, what is happening is that once I see it, I interpret this to be this way. When I'm solving, I ignore all of this. I ignore all of this. Very simple. Yes. Yes. All right. So please let's look at something. If you go to WhatsApp, to our WhatsApp group, there are values posted there. Open your practical book. So people look at that your assignments. Not simple pendulum. And we know that whenever you talk about simple pendulum, we say that simple pendulum is that oscillating type of motion that moves to and fro. Is it not true? Along a fixed path. Yes. And This simple harmonic motion falls under what we call, this is simple pendulum, falls under what we call the simple harmonic motion. Yes, periodic motions. So, with that said, let's just look at your question. I want to bring this is your assignment. So, you do it for me. You will find me that everything will go to A plus B. You can find me the A plus B. I see this. Then you find the angle between A plus B and A plus B. That's the angle between them. Then you will check to see that you are correct by doing A plus B. Is there a vectors? You will do it. Once it's vector, you will do it. We've already proved it that by doing what we did today, speaking to our determinants. Alright. I'm seeing L is here. I'm seeing one front. I know I'm not starting from the beginning to teach you about graph now because we now know how to find the points on our graph. The scale. We did it in the last class. I taught you about intercept and slope in the last class. Sherry? Yeah. So as we are looking at this, there are questions on slope and the rest. But I will not teach you the one that has food coming from your graph because we already have it. But if you read these questions from it, they say transform the equation. What they are trying to tell you is that from the equation, that is 32, and from the equation, then you should transform this equation and get slope from this equation. We will see to it. Then they are also asking us to calculate G. We will see to all those things. So we will look at the questions here, answer it. Then when you land there home after plotting your graph, even here you will be plotting your graph. So as you are plotting your graph now, that one of getting slope from your graph, and that I taught you, then you will be doing it as well. So first answer to those questions. Alright. Look at this one. That one says it's not there. What I'm telling you is to compare everything here with like straight line. Yes. We'll see if we can get this one. So this one, they didn't give you this one. They didn't give you this one. So please, every Saturday. Okay, check here. So we are thinking that we already have everything here. Yes, you already know. We will get it, but this time around, we will be assuming that we were not in the practical lab, but we will still get our answer. Okay, that is possible. And you know what? The one we get will be more correct. Reason being that I know that T on this road is equals to 2 pi L over G. Is it not true? And I know that this is in centimeter, is it not true? But from centimeter to meter, 140 to what? Will be the second step. 140 over 110, right? Please, let's get one here breakdown. Then, I'll be doing my notes. Some people are doing please, that's the notes. See, we know that 140 divided by 100 will be what? 1.4, right? In what? That's what I want. That means that when I'm doing that L here, I'll simply go and do 2 times 22 over 7 roots 1.4 over. Now notice something, please. Next to us. Remember you normally use 9.8 or 10. You see that? Please, I don't like this noise. If maybe you did the practical, the minute we talk about practical, everybody started noise. Maybe you now want to compass what you did in the practical. They are asking you. You can maybe go outside, you finish the discussion, you come inside. Classroom is for students to learn. In as much as in Nigeria, once we are doing the learning, some people just come, certain things that they are coming. Yes. But this thing you are doing is a profession. I don't know if you know. So you're supposed to treat it like your own occupation. Yes, your own occupation. Please don't treat it like your life. See, so that we don't get a list. So we don't get a list. There's so many of us who commit suicide. Please, don't treat it like your life. See, treat it as important as anything. But please, know the boundary. Yes, we find places of students maybe their friends got GP higher than their own. And you know that in some departments, like all these medicine and the rest, some of those departments have their post results is because they're based on the wall. And maybe when you go now, you've not going to that test your result, your friend come back and tell you, I checked my book and your own. You don't ask the person, you what did you get? So please, know the boundary. So we don't hear so the line. Now see, I'm got 1.4. This is my G. I can use it for 9.8. I can also use it to be 10. Yes. But for accuracy, for high accuracy, I normally tell my students use 10. Yes, use 10. But if you are looking to get slight errors, so that maybe the doctor that you use this method, you can now use your 9.8. I see it. Yes, so I go by 10. So then look for what this is from what you have. What's everything what you have? See now. Okay. 2 times 2 over 7. Yeah. You go what? 2.35 market. 2.35 1 8, Jimmy? Yes. 3.18. Now, you see, for somebody that did the practical, please let's do this. For somebody that did the practical, you will see that when the person solve anything for T, the value the person will have to not be far from your own. Maybe the person might get 6, 2.6, 2.4, 2.5, thereabouts. Yes. But you see that it will not be far, and the person will not enter 3 points. Yeah. So it will still be in a range. So what am I saying is, this is if, for example, you are not opportunity to do the practical, and the person you are copying, you don't even know if the person knows what he or she did. It's best to do this using this method. Because with this now, everything is going to be accurate because you are using formulas that are proven. Calm down. What I'm finding out is period. This is formula for period. Calm down. Now see, don't ask questions. Somebody said don't be annoyed. I'm not annoyed. Let's finish. So I got 2.35 1 8, Jimmy? Yeah. I'm not using your body. So I put here. For this first one, I'm having 2.35 Jimmy? Yeah. And notice something. Do you remember that T is also equals to T over N? Do you remember? Yes. And that N is number of special, Jimmy? Yes. Now, T is that time you were checking whether it was stealing. Are you aware? Yeah. Now notice something. If I 20. Is it not true? Now, if I choose to make this subject of formula, you will see that this over 1, it will simply mean t times n is equal to t. Please, I don't like all these cycles. I know we are being practical, but it's disturbing the class. When you think as if this class is open to discussion. I know once it's practical time, everybody wants to talk about this one, but please, let's get you understand it first. So if n, let me draw this way. This t is equal to t over n. Cross multiply to make this other formula, I see that t is equal to this, is it not? And when we use that length, which we change to meter, we already know that the time here is 2.351 Yes. Now, the number of oscillation is what? Is it not true? Yeah. Which means that here is equal to, if I multiply this, what we have? 7.36 like this. Okay. So now notice something. I'm going to be using my own two decimal places. Some people will want to use these three decimal places. I know when you are students, whenever you are plotting your thing, it's either you use two decimal places or one decimal place. Very important. Either use two decimal places or one decimal place. So I will simply say this is the same as 47.04. I say this. Yes. So this is going to make the same as saying T1 is equal to 47.04. Now, somebody will ask me, what of T2? Do you know the essence of doing this thing 2 times? Because of error due to paradox, human error, instrument error. So the more observations you make, the more accurate your reading will be. I say it, yes, but since I'm using formula, this is even more correct than what you did in the practical. Unless you give it over and over and over and over. That is why simple pendulum, whether you did the practical or you did not, once you are able to remember this, what you might be checking is to compare. So that's the only thing you have here, which is time. Notice that sometimes if you do it very well, it will be just like adjustments.
What we got is that T1 is 4 minus I1, then T2 was 7.
Okay, you got 4 points. Okay, here you got 46 points. It can be a 46. It's just 46 times.
46.5 points.
And 46.5, which is approximately 47 shilling, 47. And they say it's not that they want to shilling. You used to confirm those your limits. You already were the feeling. Now I'm teaching you that once you want to confirm your reading, this is how you go about it. This is how you go about it. So if what it got is far, maybe you got 49 points about yes. So this is what you use to confirm if you are correct, because we are not wrong here. What we are listening is just the formulas. So if your reading is far from what we are doing here, you need to go and check. So in this case, now since I have this to be 47.04, for the second one, I can just say maybe 47.05. I say it, just shift small. Because I've already gotten the correct thing. So, and this thing that I did here, whenever I apply initiative in physics, it is called manipulation. Yes. That's why in some example, you come and begin, you manipulate. So I've gotten the correct thing. But because the booklet gave me that there is a second time, and why did it give me the second time? But I need to take the readings so many times to ensure accuracy. So for that reason, I come and manipulate. I just have 0.05. So that you can look at it and say, okay, I did it twice. But I'm already doing what I know is the correct thing using the formulas. Now, the next thing is to know that another name for me is average. Is it not true? Yes. Yeah. So I'll simply say these two things, by the time I sum it up, it's 2. Is it not true? I divide by 2. Beyond knowing, that becomes my B. I agree for me. It will give the same thing. Is it not true? Yes. So I just write my punch because of accuracy. Punch, let's see what you have. For 7.04.5, Chevy. But remember, see, for 7.04, whenever we normally use 2 decimal places or 1 decimal place. So this is going to be approximately 0. Are you seeing it? Once they look at your reading, actually you got this thing, if the man punch calculator for you, you will see this thing. He did C equals to 2 pi, you get to set a punch, you will see it. But you need to come and see your own, now maybe you need to go to 06, another person needs to 05. Then the minute you look at this, it's okay, open the practical. Are you seeing it? Yes. But you're using this one to confirm everything you're doing. Now let's go for the second one. Let's go for the second one. Please remember we first started doing anything here. Are you aware? Because this one is just by the time I take the square of this, you will never stand that. Okay, I said, not just confirm, I said that the correct thing is that you use this. Which means that if you do your practical, then you're reading. And by the time you're using this now to check, and your readings are far from this, you are wrong. Because this can be wrong. Yes. So T equals to 22 times 2, which is from the formula for simple pendulum. The period of the simple pendulum is given by this. You use it to find it. Then you remember that in practicals, time is also equal to the time for oscillation all over the number of oscillation. When you take this out of the formula, you get what we have. So what you get the second. So now let's go to the second one. And please remember the difference in your own for some of you that easily pick something up and forget some details. We are not using centimeter. The unit of length is what? Meter, not centimeter, Chevy. I'm using the SI unit of meter. So I'm not using centimeter. Some people will say, but if you still give it the same thing, and it's yes, but that division with 100 is important to me. So let's do it here. So I do 120 divided by 100. What there? 1.2, Chevy? Yes. So I'm going to do one side. So that when you are doing your own at home, you check. You have 1.4 and divided by 100. This one is 1.2, Chevy? Yes. And that means that here where I'm supposed to have L, I'll now come and put 1.2 over 10. Somebody else can do this 9.8 instead of 10. Are you aware? Yeah. So now, what's everything for me? What do you have? 2.177. Okay, 2.177. Okay, please check checking is correct. Okay, because I've noticed that one person starts in this class always cause a problem. Okay, which is approximately the 2 decimal. I know that once you start using 2 decimal places, you must maintain the 2 decimal places throughout. If you're using 1 decimal place, you must maintain it throughout. There are simple things that once you look at your practical students or graph, they'll just fail. So you must maintain this. And notice this thing, you will see some people that like to do fine handwriting. Yeah? They will go and finish this one in seconds. 2 seconds. 2 seconds. Everything that puts it as you will fail it. I see, once you write this thing, that unit here, no need putting it again here. Nobody's asking you. You will say it's not useful. These things I'm telling you now, these are certain things they expect you to know.
It's 2.1774.
Yeah, for here, 2.1774. Once one person gives us answer, everybody check. Very important. So 2.1774, which is approximately 2.18. Chevy? Yeah. And that thing is my T. For this one, I have 2.18, which means I'm supposed to do something here. Remove this one will get out. Once I'm using 2 decimal places, use 2 decimal places. These are things you must note. If I'm using 1 decimal place, use 1 decimal place. Okay. Now, the next thing is to remember that period, which is speed, is also equal to time oscillations all over the number of oscillations. And we know that we don't know this one. Is it not true? Because we are not in the practical lab. That thing in a practical lab, they change. If you push it like this, all your stopwatch and be checking. You know, you might not be too fast to start reading when your stopwatch starts. Is it not true? But it will not be the same case here because this is already a broken formula. Once we do this. So our business, we've gotten this now using this formula. Is it not true? We know that the number of oscillation is 20. And anything starting on this one is over 1. Cross multiply. T is equals to Tn, which means that T is equals to 2.18 times number of oscillation, which is 20. So T is equals to what? 43.6. Like that? Okay. Now notice something. Shall you see? I'm supposed to put it here. I got 43.6. Would I just write 43.6? I write 43.what? Yes. Because I've already started with 2 decimal places. So I have 43.60. I'll be happy. So the next one now, somebody sitting beside me can now say these parts, because I've gotten the right thing. Let me show them that I took reading. I will manual N 43.61. Another person can manual N 43.62. I say it? Yes. So that's line adjustment. And why do you do? Somebody wants to ask me, but Sam, why this? Why this? If by right, you are supposed to have like 5T. Are you aware? Because the more readings you take, the more time you check, the more accurate your work will be. And by the time you take, when you do 5 of this time, do the reading 5 times, you will not say the mean will simply all the time you have how many 5 divided by 5. I ask. But 3.6. If I want to, I can put 6.1. It's up to me. See, somebody says we can have increase it our premises. Please remember that when we are doing degree of accuracy in our practicals, they normally tell us sort of ranges from 0.5 as the lower boundary, and then to 1.5. Are you seeing it? So what does it mean? If I'm even doing up to 1.5, that means I'm very wrong. Like I'm putting myself in trouble. So whatever I'm adding here should be just like estimation that falls in between this. Yes. So notice if I have 6.0 there, I just want to put 6.1. That means I say 6.2. But if you see somebody and you see somebody that will come, somebody will say, somebody will say 43.71. They forgot. Yes. So see, it's not like maybe you are, should I say, your value must be the same with my own. But you need to get that corrected. Whatever you are adding here is just slightly. You are going against it now. It's just like you are in a class now, you are in this class. Instead of moving forward, you are going backward. 43.5, you only have to be 43.5 and 43.6. That is up to 1 centimeter gap. Is it not good? So you see it's 0.1. Sorry, 0.1. Now notice that the boundary is still between that 0.5, but you are not moving forward. Okay, sometimes you get something that is left here. Yes. That's your practical. But remember that when we are here is to confirm, but let's be sure of what we are doing. We are using this one to check our readings. No, see this. You are not copying this one to stick to this one. You are copying this one, this particular one. But the one the adjustment you are adding now is up to you. Are you saying if you want to put your own grade in 5.0, it's up to you to check. Yes, when the gap is too much, it means that, should I say, what you did in the first place is wrong. So the gap should not be much.
Like 39.01 and 39.55.
39.01 and 39.55. This one is 0.5. Shebi? And what about this one? 0.1. Is it not good? I mean, the gap between these two is more like 4. Shebi? 0.4 gap. not that far now. It's not that 0.5, which is 0.5. It's not that far. Remember we said something about 0.5 being our lowest. It's not that far. It's not that far. So please, which means that whatever you are adding, you know the best way, in fact, in summary, whatever you are adding to this particular pass, I believe you did the practical. So, but when you are not confirmed and when you are looking at your work, you should not be checking. Whatever you have, is it 0.51 centimeter above what we are getting here? That's what you should be checking. Are you saying it? Yes. So, I have 9 to 6 1 okay. Then now, first for me, add the 2 up. Since it's 2 things, I'll divide by 2. Please, after this class, we do math. 43.605 like this, which is approximately here now, this is now, okay? Here we have 100 and something % correct way of doing this. Why you do practical is to make sure that whatever you are getting is not too far from when you use the actual formulas for period to solve for simple pendulum. So whatever you're doing or whatever you did in your practical, when you check your readings, it shouldn't be too far from what you're doing. How will you not do it? Do you know that there's something called human error? If you are like, let's see, you said can 1. That's why it's practical. I mean, practicalize. If you like, use 5 stopwatches. But one thing you must notice is that if the position you find yourself is different from the position that person finds himself, adjustment will be here. What we know, because as you push that thing and it's moving, it's going. The person is counting 20 oscillations. You are counting your own 20 oscillations. Shemi? How you receive your own 20 oscillation, how the person receive his own might not be the same. Yes, but what matters is that the time factor now will show when you stop, and his own will show when he stop. I say it. So you people are not going to have the same answer. There must be difference. So all those differences is what we check when we now use this method of C equals to supervalue. If I have, please pay attention. Pay attention. That's why I like some people. Some people are already using the formula to solve everything. Once we put it, this does not concern anything. See, if I have this thing to be my ball, and they don't go, and I push this thing, it's a question that I push this thing to go like this. I push it to go like this. Then come back. How many oscillations do I have? I move this. You come back. That's one shading. Then if you go again, which is this one, it's now what? If you move from here and come back again, it's what? I see it? Yes. So the number of times it completes that particular cycle, guys, it goes back to the origin. It becomes one cycle. The minute you push this, the minute you push this, the one is that you push it, and you know that if you are pushing it, part of the precaution is that you must do it lightly. Because you must feel a heavy bags. You must feel the impact before you are doing something as before. You fly it off. So you must feel it gently. The minute you do it gently, as it's moving, your own is not to be observant and see when it's coming back, when it's coming back. You are now checking your time. You on your time and you are checking it. What you are now checking is as it's moving. As it's moving, forget that it's moving. When you call your stopwatch, you are not counting till you get to 20 oscillations. So it's not like see what you are thinking of. It's not like you need to push it. If you even want your stopwatch before pushing it, you are going against it now. So the minute you push it, you on your stopwatch. Now, you will not be checking, as you push it, if you're down here, you might not start counting. And now, when you move it, you add your stopwatch, it come back. Then move again, come back, that is your 1. You go again, come back, that is your 2. Until you get 20 oscillations. You are not here to do fast and furious, you push it to start counting, no. So you take your time. What you just need is to get 20 oscillations. All this is making sense. Yes. Alright. So the guy said, let's find for 100 now. So you see that 100 centimeters is simply going to be divided by 100. See how to do? So that I get what? Let me come on. So what you do for me now as assignment, class work now, because you're going to call the graph in this class, you will get me using the same formula I've given you, the period of everything here. And you know that how we get the period is first of all, we convert this length from cm to meter. The minute you convert it cm to meter, we now come and say T is equals to 2 pi root L over G. And this G is a constant. When I start G is equal to motion, there are so many things that we are doing now that we now come and see how they are coming or where they are coming from, how they came to be. Yes. Remember I told you, the goal is always for understanding and all the concepts behind it, then we prove it. Yes. Just like what you've done now. If you did your practical, now you have the proof. You see how to check if you are correct. Any and physics must have proof. Very important. So I will do T equals to 2 times 22 over 7 roots. My L here is what? 1 over 10. So T is going to be equal to what? What do you have? 1.9 8 7.5 like this. Okay, which is approximately 1.99, shall we? To 2 decimal places, shall we? So I'll come and put 1.99. Then I'll remember that T is also equal to T over N. So over what? So if this go here, this go here, what that T is equal to T N. So I'm going to say 1.99 times 20. This is 39.8, shall we? 39.8. Do you know that as I've gotten 39.8 here, 39.8. 39.8, shall we? And I'll say this is 39.8. Now let's check something. If we say let this point part now be 1, how many zeros will I have? 2 zeros, shall we? Okay, I'm coming. Let's do something. There's something we call standard error. There's something we call standard error. Can I clear? Yeah. Okay, please do fast. When I've gotten this my T, the small t which is T1, if you want to be very accurate, to be very sure, once it has to do with time, the standard error is always using 0.001. In most cases, you see it to be 0.1. In most cases, you see it to be 0.01. Now, what will you use? What you will use is simply something that corresponds to how many decimal points we have here. This is 1, 2, shall we? Yeah. Which one there is having 2 decimal places? 0. This one, shall we? Yeah. So the minute I get this, I just add because 0.01 to it. You go to the next. 39.8. This is the accurate error for this your time. Are you seeing it? Actually, I am using 3 decimal places. What I'm going to add as the standard error is going to be the one that has 3 decimal places. Actually, I'm using decimal place 1. What I'm going to add as my standard error is going to be the one that has 0.1. Note it, write it down somewhere so you remember it. So I'm going to be using 39.81. Alright, now, the next thing I will do is to say, remember I said that is called standard error. Even length has its own. The same thing. If you're using just 1 decimal place for your length, that means you add 0.1. If you're using 2, you add 0.0. Alright, now the next thing is, add this up is 2 things. Divide by 2. And it's 9.81. Are you seeing it? Very simple. Are you understanding this? Should we understanding it? So, what you will learn for the class work, I will go ahead and check this. Using the same principle, get everything here. I'll go ahead and check. Then we'll plot the graph, and I'll show you how to locate scale. Then what we'll do with the graph, we answer all the questions in that manual. So make sure you're doing something. Make sure you're participating in this class. Make sure you are taking part in this class. It is a tutorial will impregnate you academically. Ever can breastfeed you with knowledge. Yes. Okay, so what's the point about it? Yes, now you will carry better for tutorials like 5-6 months. You go inside the exam and you give birth to a yes. Even Jesus said, follow me and make you fishers of men. Is it not true? You follow tutorial, they make you fishers of A's. Yes. And now what A? Yes. You've not seen GP of a medical or fancy student before or their results. You can have AAAC is a lie. Somebody did this thing for you. It's true. If you see medical students or fancy, all these fancy students' results, the thing will make you feel maybe they are manipulated. So do for 8, do for 60, do for 40, do for 20. Hello. Yes, now yes. Okay, wow. Yes, no, no, yes, I'm the one that started class. Yes. Yeah, you are free to enter. I think after class, we'll exchange contacts. Yes, you'll be on the group chat. Or take my number. So you'll be on the general in the one group chat. It's over 100 or 1,000 people there. So you are done teaching? No, I'm still teaching. I just came to talk to him and I gave them classwork. 090 2000 742 academic guide, yes. Once he message in our WhatsApp, he gave you the link. You do link and join on the WhatsApp and follow the channel for so we are looking so so after this class maths. After physics now we do maths. After that we will do we can address information. So from Tuesday we start. Make sure you're doing something. And you close your walk. If you want to use 9.8, you can use 9.8. You will see here the center something that is close and is correct. So instead of using 10, you can also use 9.8. Are you understanding it? Yes. Because we know that gravity, the unit of gravity is 9.8 or 10. Yes. Because 9.8 is even approximately that length. You understand it? So you remember standard error, how I say you do your standard error. So if you need your C to be whatever you have, since you are using 2 decimal places, the standard error you use for it is 0.01, that is 2 decimal places. But if you maybe you want to use your own graph to be able to 0.1, the standard error is going to whatever you get, add 0.1 to it. So that you might get this. Okay, yes. So that it will be faster. Calculate this square too. Yes. Take your time. Calculate this square too. Once you have confusion, I'll still give you the one you will take home now, because I will not do all the assignment for you, but we must do everything so that I will not use my hand as one to one. Like intercepts, you will do intercepts yourself, because I've taught you what is intercepts. Should you remember? I've taught you intercepts, how to find intercepts, that it is a line across the where the line of best fits cuts the vertical line. Also, if the time you find intercept on the x-axis, it is where the line of best fit cuts the horizontal angle. And another name for line of best fit is line of redirection. Another name for it, please, just in case if you anyhow. Another name for line of best fit is line of redirection or redirection line. Or least and to whichever way you see it, just remember it.
Oh, small.
If you are doing, let me see your hand. And for what you go for this one, if you use, remember us now, we are using overtension. That is, if you use 10.8, you are correct. Or we use the value of it that is using over 10. So if you use G to be 10, call what you have here. For your T1, call what you have. And 5 points. See, this one, 30.80. 30.80, the 5 points. What by it? 17.8. 17.8. So, what by it? 26. What by it? 30.8. What by it? 25.1. What by it? 17.8. What by it? 25.8. So what about this one? How about this? What about this? 5, 4. What about it? What about it? What about it? Okay. Then when you see the T-square, what do you have? Okay, what about it? What about it? 3.96. What about it? 3.17. What about it? 2.3. What about it? 1.5. What about it? 0.7. If we are over-accurate is the name. What you do is not that you can't clean your work. What you do is, as you are seeing, you check, you notice that most of your work will be very close to it. Now, the ones that look like they are too far from it, do you know what you do? You do manual, yes. You now adjust, shape it, apply it, yes. So this is how everything should be. So it's not must everybody get the same thing. You need the practical, those ones that are close, leave it. Those ones that are too far, now adjust.
So for those of you that want to transfer during the weekend or tomorrow or next, before you can go and collect their account
from next week. From next week.
They no grace.
Some people will come and they will hear there's no, if you've not paid, don't come, they will still come. So come and look at you, child, pity for me. Please, from next week, if you've not paid, don't even come at all. You stay in your house. Somebody will tell you, sir, I sent the money. I sent it. When you go and look at it, they will clean it when you come and put 7. You see that no. Please, make sure that the minute you click this, even on the WhatsApp group is there. The account that will appear there, you will see Okiama Joseph. Because I know some of you don't even know how to pronounce this. You will see one Abdullahi Mohammed. You go yourself here. You send the person money to come and show it, sir. I'm sending transfer to this person. Sir, what do I do? What you will do is that you pay the tutorial fee again. So please, make sure you are very careful. Even some of you, there are some of you that when you want to pay school fees, they will tell you pay it online. It's cool though, but make sure that you are doing it, you know how to do it. Even those of you that want to pay for job result admission letter, make sure you know how to do it. Because sometimes when you click those payments, you pay. The day is network, it will not affect. I don't know if you can capture it, especially jam science. It happens a lot. You make the parents, they will debit you live, but the site won't open. So make sure you are doing whatever you are doing with somebody that knows how to do it. So you don't have to lose your money. You know what you're saying from experience. Alright, so with that said, but I want to believe everybody here has paid. Is it not true? Okay, if once I okay, you will go sign. That's why when we started, I wanted us to rush and vectors because we need to do maths. I see. Let's now graph. Sherry said that the graph should be what against what? X against okay, which means our horizontal axis is going to what? Y solving, you should use standard unit for solving. Now, T is what? Second, Chevy. If you ever finish solving your graph, let's say for example, you get your slope. When you get your slope, I taught you how to get slope. Maybe after getting your slope from this graph, you get like 2, you leave it as 2, you will fail it. The only time I will leave it as 2 is when maybe what I have is L and what I have is L. And you know, the two of them, they come and say C and Chevy. I will know that CM over CM will cancel out. You know, but the situation whereby I am given anything and I am told that there is a centimeter somewhere, and I know that slope is simply changing vertical axis over changing horizontal axis. So I should know that on this side there is T somewhere. Is it not true? Which is what? Seconds. Time, seconds, or some heads. Seconds. So, and this is the same thing as saying C. Jerry? Very important. This becomes my slope. Do you know why I'm pointing out all these things? These are the little things that make students lose mind. If you saw the part I said, if you're using 0.1, you use 0.1. If you're using 0.001, you use it. All these things are little things. Then you will still remember that whatever scale you use, you must be able to write that this is the scale you use on top of your graph. You go and write scale. If it's 2 centimeter to, let's say, let's look at this on the horizontal axis now. Do you remember what we did the last time? How we went about our work? So we are using this L against what? This one. So my C square is going to be, this is going to be square set. So which means that the S is supposed to be S square. Is it not true? Which means that my slope at the end of the day should be carrying centimeter per second square. Okay? That is what my slope will carry. Now I need to check, before I can identify my scale, I need to know how to put this to scale. So I'll ask myself, the lowest value here is 20, right? Yeah. On the L, and the highest value here is what? Now, how many of these do I have? I have 1, 2, 3. Let's say this is serial number. Please, using our principle for dividing our graph. 3, 4, 5, 6, and what? 7. Alright, so I will check my graph. That's our graph, an average graph, the normal graph that we use. Vertical axis has like 12 points. If you count 2 centimeters, then if we have 12, if you do, okay, is it not 12? So like let's start from here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, there's 20 for 2 centimeters. We will check. See, let's check. 20, if we do 20, that is 20 times 7 is what? Okay, 20 times 7 is 140. Okay. But let's try that our first principle, see if it works. Let's say we do, the highest here is 140, should we? Okay, let's say we do 140 divided by 12. Let's check. Okay, that means it's going to be giving us 11.6 plus 11.6, should we? Okay, it's giving 1 time. So let's try that 20. But what we do now is that we'll let give space. Let's say 1, 2, 3, 4, 5. Please remember what we are doing is to find our scale to be short, first of all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The whole runs to 12. Shaving ahead. Now I want us to check. What if we do 3 centimeters to 20 units? Yes. Will it enter? Okay. Let's give me your best. Okay, please. Let's find 2 centimeters to 20 units on the vertical axis. That's what you have. 2 centimeters to 20 units. 1 centimeter to 20 units. Did you not enter now? Okay, so please, we've checked it. Do you know why we want to use 3 centimeters to 20 units? Because we want to cover the full length of that graph. I say it. If you want to use 2 centimeters to 20 units, it will still end up, but it will not cover the full length of that graph. Yes, it will like it's making to have a very small slope, which means the accuracy will not be high.
My friend that comes to that master's
You favored you because of how the graph is divided. So you see the textbook graph. If you use 2 centimeters to 20 units, it will give you exactly 1 fourth. So if you are using this textbook, you can use the graph here. Or you know you're not allowed to plot this like this. So please, if it's inside here, we should do it. We are going to be using 2 centimeters to 20, 4 centimeters to 20 units. Sorry, 4 units to 20 centimeters. See now? See. Let's do something. This is 20 Chevy, and this is centimeter, right? Now, we have from here 4 units, and for each 4 units, we'll use 20 centimeters. I see it? Yes. So for each 4 units, that is, if I count from here to here, which is 4 units, or you say 4 centimeters, and you cannot say 4 centimeters to 20 centimeters now. Okay, 4 centimeters to 20 units. Okay, let's put it that way. You know, sometimes you explain, guys, put more confusion to your way. So, 4 centimeters. So, we do. I'm coming. So, scale 4 centimeters to 2 units. 20 units, sorry. Please, if I explain this thing once, let's check the horizontal axis. To reach 140, yes. Yes. I asked about the people here how you see this graph. They said the lecturer asked that you should do it here. So it's here you are doing it. So please make sure as you are doing this thing now. As you are doing this, you can use this one as your raw force. So you don't get getting this one. Are you seeing it? But now when you finish your work, you are making room in your mind that anything I do here, but I'm not doing it, I do it well. So we are going to be using whatever this one is. This is 0, shall we? 2 centimeters, 4 centimeters. We want to count how many we have. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means on the exercise, the division of the 2 centimeters is 10, shall we? That is each 2 centimeters here. If you count it, the number is 10. So this is 10. Let's check. Let's check what we have here and see what we are using. Remember that this side is going to be our t squared. You see how to do? And what is the highest value of t squared that we have here? 5.5? 2. Okay, which means that if I actually do for each 2 centimeters, because the highest here is 5, so for each 2 centimeters, I actually do 1. I see it. For each 2 centimeters, since it's 10 now, or even I can do 4 to 1. See now, see. You know what? I don't want us to do 10 divided by that, this our value divided by 10, because we can also use it. That's actually the correct thing to do. We say this value divided by the number of points, the good is but it will not make it to be very tiny. That's why we don't want to use it. That's why we are not doing all these our calculations. So I'll say 0. Let me count the number of 2 centimeters. I'm talking 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and the last one. So what we are saying is this. By right, the way to find skill by right is to say what is the highest value of that particular axis you are finding. This is it, Sherry. We'll count the number of points in our graph. Here we plot them. We'll come and do this highest value divided by that number of points. That will tell us that if we do this plus this, 10 places will apply it. But I think if we are very small. So I give like okay, let's check that 1.5 for 4 centimeters for 1.5 units. Let's see if it will work. I know that from year to year, with academic that is like, from year to year is 2 units, Shebi. Another 4 centimeters. So this is 4 centimeters. Now if we do 1.5, then 1.5 another 4 centimeters. 3.0, Shebi. We are checking what will work for us. Then I have another 4 centimeters. 4.5. Then I have another 4 centimeters. So this one got 6.0. That means that I am not left with what? Nice. Okay, that's what you use. That means it's okay. We are good to go. So that means on the this is 4 centimeters for 1.5 units. I can show you this. You probably need Shebi. It's a very simple document. It's a real for person to understand. Snap it. Have you pictured it so that you pay for tutorial fee? Remember I said everything we are doing so that you never forget, so that you don't forget. You can always go to your notebook and say, when I finish my graph, when I'm finding my slope, since I have centimeters, this side I have seconds, and I know it's over. This is slope is always vertical side over the horizontal. So I know that this is going to be the center saying centimeter per second square. The right hand somewhere. So that when you calculate your slope, you remember to put it. Alright, now next time to now number this. We said that this one will be 20, 40. Say 12:30 or 1. I think 12:30. So 60, 80, 100, 120, 1. Please remember that your own. I'm on the board. Remember that our own. Your own. You are using 4 centimeter, 4 centimeter. So it is more like we are taking this and this thing means 4 centimeter. This one means 4 centimeter. Hope you remember. So with this now, we can now start plotting. So using this start plotting, let's see what you have. Start plotting, which means we'll not be checking. If what I have here is 4 centimeter, and we are taking that from year to year is 1.5 minutes. What it means is that we'll ask ourselves, how many lines are going to be inside 4 centimeter? 29, shall we? Okay, so if I have 20 lines here, we'll actually plot each line we hold for us. 0.75. Look at it, look at what we did. When we are doing something, pay attention. On the y-axis, we need 4 centimeter for 20 units. Is there? I got the 4 centimeter. I'm like, 20. I got another 4 centimeter. I'm like, 20. Make sure you're doing something. Shall you remember this is not the graph we used to do this in? Yeah. The lecturer said you use this graph. Yeah. This is the graph we used to check what we are doing. And I told you when we started that whatever you are doing here, that you are doing it so that you are in your mind, mental adjustment, that at the end of the day, when you get home, you now transfer into this. This one is for learning purpose. So this is not the graph, we are using it still. It cannot enter now. Look at your graph now. Look at the graph we used to take these measurements. And this is where the assignment is to be entered. Are you seeing it? So you that want to use your own graph now, it simply means that the same way we make this adjustment, you can even make your own adjustment by saying, we know that naturally the scale can be gotten, highest point says 140. We'll ask ourselves, how many points do I have in my mathematics for you using this thing now? How many points for the 2 centimeter? If you get maybe, let's say 8 points, you do 140 over 8, which means that whatever you get here is going to give you each one. By the time you add it all to 8, it will give you this 140, the last points. And so that's how you do it. That is the normal way of finding CO for the graph. But this one, we are making adjustments. Now, yeah, you can. No, you can. See, someone is asking if we have a graph book now. If it's compulsory that it's constante, it's not compulsory. Hope you know. So if this is our graph, somebody is asking, is it compulsory to always start from here? Yes, the last part of our graph. It's not compulsory. If you learn, you can start from anywhere, let's say here. But at the end of the day, that's why you see some graph, you come and do something like this on it to show you that they did start from the origin. So if I like, I start from here, but we are starting from this point because we want our graph to cover the full sheet. We want it to cover, should I say, more than half of our graph. We even talked about this in our last class. So I think about this, I think this was a tool that now come when we started graph plotting. Alright. Please make sure you're doing something. Not where we are. Make sure you're here. It's not a must, but for higher accuracy, you do more of it. What we are doing is to ensure accuracy. accuracy. Some people let go of the thought, they have to into question by make sure you're doing something. Make sure you're doing something. Please, this is practical class, not in the class. Make sure you're doing something so that I will use what you've done. So that I will use what you've done now. To get to tell you how to get to know on this level, we solve the questions there. Please, what we are saying in summary is that there is no restriction. If you want your own, you just modify your graph like this and start. Maybe inside the middle of your graph, just start. No problem. But what we are doing is that the more space you have with your graph, the more accurate your work will be. That is why even when you are plotting your slope, let's say we have our line of hospital. If you see somebody that come here and plot his slope triangle, the level of accuracy of the slope will not be as accurate as somebody that uses our own slope like this. I see it, yes. See, shall we use here today 4 centimeters for 20 units, right? Which means, and each 4 centimeters has 20 lines, right? Which means that we have how many lines inside this vertical? So we have 4 divided by 20. 0.1. No, I'm talking about vertical. This one, yes, this one will have each line to be 0 points. Each line on the horizontal axis is equal to 0.075. Is it good? Then check for we should have 0.2. Is that what you have? Okay, so I have that each line on this side is equal to 1 here. Please, hello. Your mouth is disturbing the class. Your mouth is disturbing the class. Please, that's the noise. What we said is let's stop the graph. We did not say let's stop. Are you enjoying the class? Should we stop? Please, if you want us to stop, we stop. Because, hello, you're disturbing my class. Whatever you're showing anybody, show it with hand, no mouth. I'm coming. Yes. Okay, you say you want to start here. Try it and you have to start there. Please see. hello, there's the noise. When we teach you and you have your own adjustments to make on your graph, it's not for you what you feel or what your graph is giving you. But I know that when we started this is the graph we picked up. Shall we? And we notice that 4 centimeters for 20 units perfectly cover this graph. And then we know that if we start here and do 4 centimeters for 1.5, it perfectly enters this graph. Now, if at any point you want to use a graph that is not this one, I will not be the one to follow you and be checking it. Rather, you will just use the normal method to check it yourself. What you will do is on your graph, how many points of 2 centimeters do you have on the horizontal axis? If your own gives you 8 or 10, you will not come and say on the horizontal axis, what is the highest value? Which is this square, 5. You do 5 divided by 8. That is the number of points that we enter that you do. Since you want to use a graph different from the one we used to make our adjustment, you now take vertical axis. If your own graph is not exactly like this one, your own gives you maybe, you count number of 2 centimeters or 4 centimeters. It gives you like let's say 7. You check what is the highest value on this vertical axis because it's anywhere listed as our vertical axis. If this is 7, highest value is 140. Look, 140 divided by the number of points, which is 7. Whatever it gives you, that's what you use here on your own graph. But the one we are using is because we use this graph to make our adjustments. So there's no need you calling me to come and check your different graph to be sure if it's the same thing. It cannot be the same thing. So if you want to do it that way with a different graph, the only thing you do is use our normal method, which is the highest point of the horizontal axis divided by the number of points your graph is having. The highest point of the vertical axis divided by the number of points your graph is having. Outside it, you can ask it to our adjustments. Well, see, your own is a prime graph. Are you doing? Should we not start plotting our graph? Should we start plotting our graph? Yes. Now see, please, if I have this to be, we say that each line here, since from this end to this end, that each line here, we will decide that say this is 1.5. Shall we? We will now need 1.5 divided by how many lines are inside this 20 divided by 20, and you got that each line with 0.75, which means that each line on the horizontal line, the horizontal axis is equal to 0.75. Why? For the vertical axis, we use 4 centimeters, and at the 4 centimeters, we have 20 lines, and the number of units here is 20. So we do number of units, which is 20, divided by the number of lines inside here, which is 20, which means it will be equal to 1. That means that on this vertical line, we have 1 centimeter. Each line is 1 centimeter. Alright, so at that point, we've looked at that. So now the next thing is to say, for my L, which is 140, shall we? The next thing I have is 5.52. Let me push this way. If I push this way, my 5.52 will be somewhere here. See how to pay attention. So please let's check something. If we say that each line here is 0.7, is 0.075, I want us to add 4.5 plus 0. Remember that we are going to be having on this total of 20 lines. Let's put 20 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, then 20. Alright, so now what I want you to do for me is to say 4.5 plus 0.075. 4.575. For that man, you to be the way answer. So how do you do it? And we know that this is going to be approximately 5.56, 75 should be 5.56 that 7 what? It's graph we're trying to look at. Now, add 0.075 to that 4.575. So this one is 4.65. Now, add 0.075. If you are paying attention, you must be following. So, I'll have what? 4.725. Now add 0.075 to 4.725. 4.8. Add 0.075 to 4.8. 4.875. Do you know if you are driving motor, you don't come and sit on the stand and start driving, you should be going straight. If you see block, you are supposed to be going straight. You will do small adjustment and continue shaving. Those adjustments, if this is called yes. But you watch. 4.875 plus 0.075. 4.95. Now, 4.95 plus 0.075. 5.025. Remember, we are looking for 5.52. That's why we are doing this. Now, 5.025 plus 0.075. 5.1 plus 0.075. 5.175. Okay. Now 5.175 plus 0.075. 5.25. Okay. 5.25 plus 0.075. 5.3. Okay. 5.325 plus 0.075. 5.4 plus 0.075. Should be this one. 5 points. Now 5.475 plus 0.075. 5.5. Okay. All right. Now see something. 5.55. Let's just complete it. Plus 0.075. 5.6. Ahead. I've got to what I'm looking for. I've crossed the value of 5.5. Yes. I'm going to 5.625. Now notice something, which means that 5.52 falls in the range of 5.475 and then 5.5. Are you seeing it? Yes. Now we need to ask ourselves. Please watch. Pay attention. That is when mathematics is good. Let's bring out this thing, for example. If I have 5.475 and then I have 5.55. Let's say I approximate this to this point. What would this be? 5.5, shall we? What if I approximate this one now? This will be 5 points. I see it. So this one is off. This is off. That means that whatever I'm doing now, since I have 5.475 around here, shall we? Yes. So which means that a bit after 5.75 before I get to 5.55, this is where I should be having my 5.52. I place it on. This is what we call manipulation. Very simple. Very simple. I said it in between the two. That is where you are picking your point. Somebody will say this one is 5.5. But notice that this makes it automatically greater than 5.52. So in between is where I'm picking my point. So I'll mark it out with asterisk. The next one is 4.75 on this side. I'm using this 4.75 because I've already gotten it before we do it. Now let's check. Somewhere here I got 4.8, shall we? Please pay attention so you see what we are doing. Somewhere here I got 4.8. Then 4, okay, let me write it out. I have 4.8. Then somewhere else I have 4.725. Is it 5? Yes. But what I'm looking for is 4.75. Shall we? And if we be honest to ourselves, approximately 4.75 is the same as say 4.8. Is it not true? Yes. So which means that it is simply the same as saying in between 4.7 and 4.8. In between, I just pick that box there. Trace it on. That is my 4.7. So see, I have 4.725. I have 4.8. This is 4.8. I see. This is 4 points. Is it 4.47 or 4.725, Shelly? Okay, this is it. This is it. That means this one is 4.725. So in between these two, then, and that is for what? 120. What we are doing here is not hard. It is not even, should I say, far from our answer. Reason being that if you want to do approximation, some people will say, why don't we just call it 4.75? Why don't we call it just 4.8 and use it like that? Remember that every little thing that is important to us. I see it. So that is why we don't just call it 4.8 and use it like that. So all those in-betweens, that's what we're using our line to do. Is it confusing? It's not. So that is what we call manual method. Alright, let me mark out. Now the next thing, I have 3.96. Okay, that one is a bit far from us. But we will do the same thing, the same approach. So I know that 3.0 now, each line here, each of these lines, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I'm doing the human method. My friend is laughing. But you know what about the thing? It's not hard. It's not hard. So what you do for me now is 3.0 plus 0.075. What do you have? 3.075. I add another 0.075 to it. I thought I made a calculation as question. I don't do more. 3.075 plus 0.075. 3.825. Like this. Or this one. This one. And the next one. 3.725 plus 0.075. 3.825 plus 0.075. 3.9. 3.9. Why are we doing it? Because this is tutorial. Are you here? Yes. It's a lecture that explains it here. We do it together. That is why I'm that you come with graph. And since even your lecturer now said you should be using this one, you see that they make provision for that. So once you are coming, if possible, you can just go to back. For example, if you photocopy the lines will not come out together. Maybe you know. But I think once we're able to use this one and do it, having in mind that we're going to just alright, look for me. 3.9 plus 0.7075. Okay, so somebody said it's not supposed to be 3.9. They say it's supposed to be 3.825 plus 0.075. Okay, that means this one is supposed to be 3.9. But the first one here is 3.075. Okay, please see. After this one gave us 3.075. Add 0.075 to it, what do you have? 3.15. Thank God I have students that are sharp in this class. So it's supposed to be 3.15. But at 3.15 plus 0.075. 3.2. Okay, 2, 2. Fire. Fire. 3.377. Keep our clue there. 3.375. This is what we call students. 3 points in it. 3.5. 3.6. 3.7. Okay. 3 points. And I'm looking for 3.96. Okay. 3.97. 4.0. I've got what I'm looking for. And let's look at this now together. See, if you come and look at this, 3.96. Naturally, 3.96 is the same as saying what? If your percentage is 4.0, is it not good? Yes. Now, let me write it out to one side. Now, let's go back. But remember, we are not approximating because we need the accuracy. We need to be highly accurate. The more decimal place you have, the more accurate your work is. So, I'll come here. I'll look at this. This is 3.9. This is 3.9. And it is not up to 3.96. And over here we have 3.97, which is the same as 4.0, shall we? So which means that we need to do, see, first of all, if you really want to be totally accurate, because this thing will look it very tiny, you need to ask yourself, if you divide 0, shall we said each line is 0.075, shall we? Yes. If we divide it by 2, what we have? Remember, our goal is to be highly accurate. 0.037.5. Okay, now we have somewhere here. This is 3.9, shall we? 3.9. Then we have 3.975. Now, which means that if you add that 0.0375 to this, you are having around 3.95 thereabouts. 3.9375, which is still not up to 3.96. Is it not true? Which means that by the time I have this, it has to be 3.9, and I have 3.976. Even if I divide this into 2, my 3.96 should be somewhere here. Don't worry, it's not going to be easy. We are still trying to bring our point. We'll come to you. Please, what we are doing here, is it making sense? Yes. So, in between, because accuracy is very important to us. So, in between here, we've been able to find out that this one will still be 3.93. So, which means that somewhere here, if I happen to divide, since this is 0.397 or 375 on both sides, if I still divide this by 2, if I really want to be accurate, what do you have? 0.019. 0.019, shall we? I am adding to that your 3.93 whatever. It gives you 3.9565, shall we? Which is the same thing. So that means that on this side here we have our 3.96. I see it. So let's go back to that. We have this before. So when you are using your meter or your pencil, remembering everything I'm saying, it will not be difficult. Because that accuracy, the level of accuracy is highly important to us. So I have this. Now for that of 80, I could have said just be using to one decimal place to do it to your record, we need to be very accurate. Since we've already started this with serious language, that is why we're going to do that. So I now for 80 on the vertical axis for L. Then for the G square, 80 plus on 3.17. So let's check for 3.17. This is my 3.0. The next thing is 3.075, shall we? Now the next one is 3.15. Is it all true? Then the next one is 3.25. And I know that first of all, let's check. I know that 3.17 is approximately 3.2. Do you agree? I always do this so that we see where our range is. So we should be falling in line with, we should be in between, whatever we are doing is going to be in between 3.2 and 3.15. Yes. So it is not there for us to say, since dividing 0.075 by 2 gives us 0.037, shall we? Now add to 3.15, add 0.0375. So 3.15, let's in between the two. So 3.15 and 0.375. Let's see. So it's giving us 3.1875. Shall we? So you see that notice is here, the half of this. If we come and bring this half, what he said is that it's going to be 3.18. Is it not true? So it is slightly greater than 3.17. Are you seeing it? So which means that I'm not going to be taking exactly this half. So in between these two, is where I'll be taking as my 3.17. Is this making sense? It should make sense. It's not hard. It's not hard. Alright, let's go to the next one. The next one is when I have, let's say I have 60. Then I have 30.81. See? Is it 30.81? Check. 60, then I have 2.37, sorry. 2.37, and that should be something here. Is it not true? So please, using the same principle, get out your 2 points. 3 samples for me, let me go and check. Get out something for me, let me see your work. Read that. What are you doing? Vertical step. Give me vertical step. On that. Okay, so the one that is off. What do you want, Jerry? And you just draw your straight line that will be parallel to this one. The same one we did for the other one. And just straight line that will go there. You see, let me show you on the board. Let me show you. See? You're having something like this as your best fit. And you have something like this that is off. And you have something of this nature that is outside your line of best fit. I said anytime you want to get your vertical step, since it's 1, actually it's 2, we can get from that. Since it's just 1 here, with my inner rule, I will draw a line that is parallel to this. Parallel in the form, in the sense that it will be exactly the same direction.
Okay, so if you pass through that aspect.
Yes! The student has studied it is what vertical step I said to say is the line of the points that did not enter the line of best fit. So if you pass through that, your asterisk parallel to this. So once I've gotten it now, it will be faint line, calm down. Once I've gotten this line, no measurement, I can project it to any length, but faint. I'm going to have a straight line, vertical straight line. When I'm doing this vertical straight line, so that I can place it to the vertical line, that y-axis, or place it to the y-axis, down. Yes. So the difference here, let's say I get 10 here, get this to be at 10, I get this one to be at 5, but that 10 minus 5. Whatever it is my which is vertical step. That is the point. come again. Only Jesus will come again. But I will repeat. I said, anytime you want to get error is slow. You remember that, for example, let's say you finish doing your own now, just like I'm doing this one, and I want to get this line of best fit, I'll make sure I place my finger rule. The rule of thumb is that, please let's notice, that when you have got your line of best fit, or you go into the direction line, or line of this angle, that it must pass through at least 3 points. So if I draw this now and it pass through this point, and then maybe it not enter this point, it can pass through more than, but at least maybe now go somewhere like this, and come and have points like this, have another points like this. What we are saying is simple. We are saying that when we want to get our error slope, which is SG equals to 4W over NR. Error in slope. Even if they did not tell you to find error in slope, you always find error in slope. I said it in the last class. Even when they did not tell you what is the error in slope, you find it. Very important. Because you cannot do that slope and there is no error. So I'm going to tell myself, this W is not because as the point off. I'll come and say, down here, how many points is off? How many points went off? Or should I say, how many points do I find that do not enter this line of this? It's just this one, this side. And I'll ask myself, which one is the closest to this line of this between these two?
The other one.
This one, shall we?
Yeah.
I'll draw a straight line that will be parallel to this. With my meter rule, I will try my best to see that it is parallel. I'll draw a straight line. If I want to stop it here, no problem. If I want to continue going straight line, no problem. Even when I do this thing towards it, if I wanted it to stop it, no problem. Then I will still draw straight. I don't have to make it pass through this one, because I've already gotten the closest one to the line of best fit. Now the next thing I will come here. This is the only one here. I'll still draw another parallel line to this line of best fit. Straight. If I want it to be short, no problem. No problem. What I'll have is to come here, place my meter rule, and draw a straight line, vertical line. Once I've gotten this vertical line, I'll mark out this point, I'll then use my meter rule, project this to beat the vertical line, the vertical axis. Or then I'll project this to lead this down. The minute I finish getting this, I'll ask myself, notice that this is 80, that means this is 60. That means some area should like, let's say, 78. Is it not good? This one is 60. By the time I do 78 minus 60, what do I have? 18. Sherry, that means my W is 18. I see it, my W will be 18. Why this ending stands for number of observations, and total number of observations will be here is 7. Is it not true? Why R stands for your range, the highest value on the horizontal axis by the lowest minus the lowest value. And on our horizontal axis, this is the highest value. This is the lowest value. This minus this gives you this R. I see it. So by the time you get number of observation, get the subtraction, then you do 4 times the vertical scatter and divide. That is your error in slope. Vertical scatter can you do it? Must you project it to this place, to the vertical axis? Okay, if it's the loss, you can take advantage of it. Any points. Now, one thing you must notice is that anything happening whenever you are dealing with 2 dimensions, whenever you are dealing with y-axis and x-axis, anything happening here is called collinear. It's linear. Reason being that I'm coming. Reason being that if I have, for example, a point this side, and I have a point this side, let's say this is 10. Let's say the next one is 4. Let's say here it's 5. And the next one is 6, shall we? Okay. I have this. Now let's say I come and check at this point. To this. Now let's say this forms my slope. Now notice that if this is 4, 4 minus 10 will give me what? 1, shall we? 1, right? Now 6 minus 5 will give me what? 6 minus 5 will give me what? 1, right? And 1 divided by 1 is 1. Now, it will be the same thing with if I call here somewhere, maybe I have 7 and 8. And then I trace this. And then I trace this. Then maybe somewhere here, I have, for example, this thing falling on 5, and this thing falling on 6. The two will give me the same value. If I say my slope, now, if I say my slope is somewhere here, if I say my slope is somewhere here, you see that 7 minus 7 will give me 1. All over, 6 minus 5 will still give me what? 1. So anything happening on the vertical and horizontal axis is collinear. Any point you want to do it, it will still give you the same answer if you are correct. Don't worry, we'll do it. Don't be fascinated. G is gravity. G is gravity, but you can actually calculate your slope using that formula. Let's start trying to answer those questions, please, so that we can have an up. What's your question? No, they don't always ask you. But I'm saying that anytime they give you anything graph, even if they did not ask you, find the error in slope.
What is all your
Yeah. Okay, so your point is down the line, which is not possible. But if it enters, why I need to calculate the error in slope? There is no error now. I see it. There is no error. Which means that, thank you. Which means that if you are doing magic, you like to do manipulation, you like to manipulate all your line of best fit, you clean, so that everything cover your line of best fit. When the examiner look at it, they will know you did magic. But ask. Can we approximate what? Everything has to be zero. If we want to do that, no problem. But see, when we are not doing it, remember what we started with. When we started with, if we approximate this to be zero. Are you aware that, for example, this 7.5 now, 7.0 is different from 7.5 or 7.5. Are you aware? So we cannot do it. We always see as we want to change it for this month, this will simply become 8 now. It's not 8-0.
Can we read like that?
Why do I do like that? I won't have to do like that because if I want to use 2 decimal place, this is actually what this is in 2 decimal place. That's our resolution. It's not about affecting all of them, it's about doing it for them. Before using the approximation, I got 4 decimal places on here, I approximated to 2 decimal places. So what you are telling me now is what the approximation is called rounding up. And I'm not supposed to be rounding up, so I can't round up. So if I round this up now to become 6-0, round this one up now to become 8-0, then it does not fall into the group. We use the length in meter when we were solving for L because in 2 pi with L over G, L there must be in meter. Even if you use centimeter, you must still remember that you must divide by 100. This value we are given is in centimeter. This value we are given is in centimeter. To find our 2 pi, the L there must be in his SI unit. What you are given, whoever gave you this, know that meter is the unit for length, but they still gave you centimeter. So we must use what we are doing. Very important. N is number of observations. It's a scale we use. We use it when we're finding that. That is another attention. Please, hello, there's your Sam, this one, Sam, this one. When we are doing that, we were talking about it over and over. Have you not noticed that most times when I say one thing, I say it. So you take note of it. Not when you wake up, you now come and ask me, Sam, this one. Don't worry, we are making a video on this. Can you hear me? So, yes. So once we are through, we'll be testing, because we know this practical, once you get to simple pendulum, we need you to be highly accurate. Once we get our finish, we post the video on the book. You take your time to watch it. The reason is that your practical is highly important. You need to remember everything I said, all those things only 2 points that I can do. Listen to it properly. Let it speak. So that you don't make mistakes that will cost you money.
No, I don't think it's
Okay, so please, what I will just find here is I will just find the slope, the standard error. Listen, my watch. They give me so that I'll get Z equals to 2 pi root n over g. Then they ask me standard error in G. Some of you will not pay attention. The minute I finish, you just come and ask me value of G from the graph. That is the most important thing I know. Like I see, please, that person that has this value, please listen. The person that has this value, read what they say we should do. 2 pi root n over G. Now, they get you to do what? Now. Hence calculate G. In the question, they give us G to do what? Hey, Lord of Jesus. So even if they don't text them, you cannot correct them. I don't see that that is G. I don't see that that is G. Have you ever seen any equation of, okay, see now. Are you in Jupiter or random or which one do you call it? Or Pluto, which one? Like you will not be using G to be 8. It's not possible now. It's not possible. So this is G I wanted to write here. So they say we should transform this equation and find the slope. Is it not true? From this, I remember that your slope is simply n over t squared. Do you remember? Hope you remember. So what I want to learn. Hope you are learning something. Are you learning something? Hope you are not hungry. Are you hungry? Yes. Don't worry. Shebi, I've been promising to buy you, but I've seen a lot of my for you, Shebi. When Tuesday, I will come with it. Yes. Today is not today, I'm the end of the money. From my survival for me to see, equals to 2 pi root n over G. I can separate the squares of both sides. Are you aware? If I take the squares of both sides, you see that 2 becomes 4, pi becomes pi squared. See that? This square will open this. Shall you know? And distribute it. Instead of saying 2 pi squared, 2 pi r squared, then it's L over G all squared. This will open it. So I have L over G T squared. And see, what this means is that I can now say divide both sides by 4 pi squared. Are you aware? I divide by 4 pi squared. Divide by 4 pi squared. But that is it. This will get out. You have arguments ahead. You see you well. Alright, this will now be t squared. T squared all over 4 pi squared equals to L over G. Is it not true? We can say cross multiply. Is it not true? So that this becomes GT squared equals to L over 4 pi squared L. Shall we? And remember that this, I want a situation whereby I will have this. This is my goal because that is my slope. So I can say
change the L over change the T square. Just still.
Yes, now. See that? We are this one, shall we? Yeah. This is where we are. But we say divide both sides by pi. Is it like this square again? Yeah. Okay, by t square. If we divide both sides by Okay? This will cancel this. Is it not true? And I can still multiply both sides by 1 over 4 pi squared. Is it possible? So I can do times 1 over 4 pi squared times 1 over 4 pi squared. Is it true? So that this can cancel this. So that I'm left with G over 4 pi squared, Sherry, is equals to L over Z squared. Does this thing look like what you do? Sherry, when we did our slope, it was the length all over 3 squared. When we did our graph, sorry. Is it not true? And we know that, see, we know that on our graph, for example, we know, for example, that if I have, for example, velocity over seconds, the gradient, the slope of velocity time graph is acceleration. Is it not true? Which means that whenever you plot velocity and time, what you are getting is what? Acceleration. Which means that if I plot m over t squared, what I'm getting is its gradient, which is its slope. So this is the formula now I will use to solve the slope of this. So I will answer that L. Can I hear you? So I'm going to say that, let's finish it here. I'm going to say that L over T squared is equals to G. We use our G when we solve there on the board. We use as 10, Sherry. Some people can use 9.8. So I have 10 over 4 times pi is what? 22 over 7, and notice that it's Ghanaian square. 22 over 7, and notice that it's Ghanaian square. So, whatever you get here is your slope. Very simple. Very simple. I punch it here for me. Punch it, punch.
That is no need for graph.
You will still do your graph, but remember, it's the question. We are using the question. See the question. He said, transform the equation and determine the slope of the graph. I see it. So we have to transform this equation in such a way that we get our slope from it. Then we use it to determine our slope. So when we get our slope now, we'll still go back again. The equation also asks us that we should find G as well. So, punch for me, what do you have? No, it is not the better. So 0 point what? 2531. Okay. So 0.2 and 3, 1. Now notice something. This is in cm, Sherry. This one is in centimeter. Sorry, second square. This one is in centimeter. So this is approximately. I'm not rounding up. I'm doing approximate, not rounding up. So I now have 0.25 cm per second square. Very simple. This is my slope. Very simple. Just like that. So always take note of when a question is asked and they tell you to transform an equation and then find something from that equation. What you must do is to make sure that if the slope they're asking you, look for a way to find what values equal to what your slope is. Then solve for what is equal to get your slope. Very simple. So 10 is a constant for, see now, this is G, G is 9.8, another person can use 10, we use 10, then 4 times 22 over 7, then the pi is squared, so you are very activated your answer, very simple, yeah? You are asked. You got 25 points for your graph?
From my graph.
Okay, yes. No, you are not wrong. See, you are not wrong. Reason being that you what you plotted on your graph and your readings, whatever it is, you can still make amendments by checking if there's something you missed or not. Go over it, over and over. It doesn't mean you're wrong. But see that what we have here, we are using what we have here from the equation. They say that we should transform the equation and get the slope of the equation. And the only way to get the slope of the equation is by making this solid of the formula, which is L over T squared. And this is what is the loss. So if you plot it, because what you have as your slope is not what another person will have. So you need to check and be sure. So when you have done this over and over, whatever answer you have said should not be too far from what we have here. You said? What's that? See, you put your graph now, you get your slope, or you go and answer that question. See now, see, I don't understand why you're doing should we. See, there's an equation here. Transform the equation t equals to 2 pi root L over g and determine the slope of the graph. Then I said, hence, calculate g. I see it. So even as we have this equation, we can still get g from this very equation they give to us. If we want to find g here, we can still get g subject of the formula. And we get g. Let's try it. And when we solve for g, g should not be far from 9.8 or 10 thereabouts. Because we know that g is a constant. So let's say what's the need of finding it. That's the question now. So let's try to find g. Be fast. Now please, for standard error, I want you to know that the formula for standard error in G. Please, there is difference between standard error and standard error in G. Pay attention. There is difference. Your problem is that you don't want to listen. Then to ask what you want to ask. The important thing is pick the ones I'm making. Any other observation, any other condition, you now ask. There is difference between standard error and standard error in G. The question asks us to find standard error in G, not standard error. And as it asks us to find standard error, I will just use SG equals to mean deviation. I will do SG, that is standard mean deviation, all over roots n, and n is my number of observation. No, I think they asked me to find standard error. Okay. This is the formula to use. That is standard mean deviation all over square root of the number of observation. But since they asked me, since they asked me to find the standard error in G, I'm going to be using SG equals to G multiplied by the square root of the power of, notice that the two things I'm looking for here, for this graph, is all about L and T squared. Is it not good? What is the power of this L that is here? 1, Sherry? Yes, power of L. So L, that is 1 times the standard error in L. What did we use as the standard error in L? 0.01, Sherry. So times the standard error in L, which is 0.01. In L, all, so everything neighbor divided by L itself. Divided by L itself. Now what is L? I'll just go and check the highest value. Any point in L. If I want to use the highest value of L, what is the highest value of L? 140. Another person can choose to use any of those values, maybe 120. Allow me. See, this 140 is the highest, Sherry. The highest value of L. I'll use L to 140. Now notice that I will have square root of everything here. I will not even complete what I'm about saying. Some of you want to ask questions. Relax. I have this. All divided by L. Now I'll do plus Now, the next thing, notice that I have t. I'll do plus the power of t. The power of t is what? This t, what is the power here? This t that we're seeing, what is the power? So the power of t, which is 2, now, times the standard error in t. How many decimal points is our t? Was it 1? 2, which means it's going to, the standard error is going to 0.01. So, times the standard error in t. And please note that whatever you are using as your t here will be the same time in correspondence to your length. So if I'm using that length of 140, the time in t here is what I'm using. If you want to use that of 120, the t for 120 is what you use here. So divided by t. Now notice that I'm taking the square root. Are you seeing this? I'm taking the square root and I'm squaring this. So this is going to be my standard error in G. This is my formula for standard error in G. Standard error in G. It is different from standard error. It is different from standard error. Standard error is simply mean deviation. I'll show you how to get the deviation. All over number square root of number of observation. But when you're talking about standard error in G in gravity, it will be gravity multiplied by the power that your length is having, and the elder is having 1 at this power times the standard error. And the standard error we're using is the one that gives us, because it's 2 decimal places, 0.01. Then all over the LED cell, if I'm using 140, another person can be using 120, but I'm using the highest value, which is 140, then plus the second for time, power of t. So we're ready to solve this. That's the last one. So have you gotten G? I told you to solve for G here, so that we can solve this one together. Once I thought I don't finish. Four W over M is for error is slow. This one is for standard error. Standard error. This is for standard error. Not in G. In anything ground. Anything ground. The standard error is calculated by doing mean deviation all over root n. Number of observations. Yes, they all have the same sign. Yes, yes. You see what? Have you, listen, that is what shows if you are a genius or you are brilliant. Remember, look at this. This is 0.25 centimeters per second, Chevy. Because of what our graph is giving us now, if maybe you now want to convert your own to meter, you now come and do centimeter to meter will be what? You see, remember to look at it. I want to do this. Can I do it? Next time, centimeter to meter is what? Meter to centimeter is what? So fear to say yes and yes. You will see everybody asking you, Sam, this and this. The minute you ask it the next time, everybody will forget. This is kilometer. This is a kilometer. Those of you that think that this is the candidate. This is meter. This is decimeter. This is centimeter. This is millimeter. I told you that if I have 100 millimeters, it is the same as 10 centimeters. Is it not? Which means notice this way. I'm moving from millimeter to centimeter and divide by. Are you not seeing it? Yeah. I'm moving from millimeter to centimeter and divide by what? 10, because I'm considering this to 1 and this to be 0, which means this is division. Is it not good? While if I'm coming this way, this is what? say is a slope for the particular person you're giving it. Then I think whatever is required, use it to solve. It doesn't change the fact that you can get your slope from here. Get it here. See now, once we get it, you see no option for this. We're going to write the one. If it's not just we get it, we'll solve everything we'll solve at the bottom here. Everything we just solve at the bottom, we'll solve it in this space. Look at this. See, your problem is that you don't want to see. Your problem is that you're not confusing yourself. You're giving an equation. Don't need to transform the equation. Use it and find slope. We use it to find slope. You're not telling me. You're not telling me. You're not telling me. Should you abandon your graph? Should you abandon the readings on your graph? And that should you not use the readings on your graph to find slope for your graph? What are you saying? You're giving an equation. Say transform the equation. What is this now? They're giving me a question, transform the equation. Listen to find slope. I did that. Yes, which means that when you solve with your graph, you should be able to find your slope normal for your graph. And the slope on a graph is simply nothing but doing vertical axis divided by the slope. Very simple. There's no we should find G. See, we can as well find G now. But see, when we go to G over T square equals to, what did we get here today? We have T square equals to 2 pi L over G. And divide both sides by 2 pi. This will cancel all over 2 pi. Then, I don't have to do everything. You will do some yourself. Because the way some of you are doing as if you don't even want to get time to think about it. See, I will have T squared all over 2 pi is equals to root N over G. Shall we? Yes. Is it not root? Yes. I'll then ask myself, what do I do so that I can eliminate this? Because I want to get G. Sorry. Okay, space one here. Thank you. So let's say take the squares of both sides, shall we? This will cancel this. So that if I take the square of this can become this square over square equals L over G. Is it not true? Yes. Since I want to make G subject of the formula, I can say multiply both sides by 1 over L. I said it times 1 over L times 1 over L. Hope you understand this. So that this will cancel this. Is it confusing? So that I have T squared all over 4 pi squared L equals to 1 over G. Shall we? Okay. And I know that this is not exactly as saying if I cross multiply, because I want this G to be a subject formula. So if I cross multiply this becomes GT squared, right? Equals to 4 pi squared N. Are we together? Yes. Oh, we're still together. So I can just say divide both sides by what? T squared. So that this will cancel it. So G will simply be equals to 4 pi square over L over T square. Notice that this thing is the same thing as saying 4 pi square times L over T square. Are you seeing it? Notice that your G, this your G, if you watch this, it should be giving you a value that is 9.8 or thereabout. So 4 pi square times your L over T square. That is what we have. So please, if you don't understand, I will post a full video on this. But for you to find your G, this is the formula you must use. The G they ask us to find, they say calculate the value of G. That is the value for G. G is the constant naturally. So if you solve and it's not giving you 9.8 or 10, you are wrong. I seen it. Yes.
You can go outside, buy bombs. There is ones here. Don't go to the park. You are not smart. Don't buy, use your bag here, buy bombs. Now buy Colombia and seal coffee in man. Buy Indian coffee in man. Buy Colombia Indian coffee in cheese pack. Buy Colombia you can buy cockroach. You can buy bombs. Buy bombs. I get money now. Who got it? Yes. So thank you very much. I hope you enjoyed the class. You can clap for us and clap. No, I thought you did that.
Alright, so see, please, we need to be fast.
You understood something, okay?
I just asked over this because G over square, Shebi? And please, we need to be fast. Here in the labor, the thing here use labor, we need to have a second square. Is it not there? Are you aware? We use 1.4 instead of 140 here, right? And once we solve here, what we have here, what we have here. Are you aware? When we solve this thing, we divided by 4 I square, what do you get as the beta answer? 0.
Yeah, go bless.
0.25. Is it? 0.25, that's what we got. And it's a meter per second, are you aware? No. Centimeter per second is what we use on our graph. Do you remember? Centimeter per second. Because remember, that is what we need to know. Notice, this is Shebi. I'm still going to carry to 1.4 Shebi. All over, the T for this arrow is when you do T square, it's 5.5 watts. 5 to Shebi. If you divide this now, which is, this is a meter, this is a second, you will still get the same 0.25. Is it not true? Which means that it's actually meter per second. Are you seeing it? Now, when you now take this now, this value that you have to centimeter, which is what is on your graph. Your graph is centimeter per second, should be? Yes. So you see that you get the same answer, which is 25. Are you seeing it? So this is equal to 25 centimeter per second. That means it's correct. And every one of you will be correct. Once you still do it from your graph, then you will still be correct. Your graph will not give you value in centimeter, which is 25 or 25 points or whatever. Are you seeing it? Yes. And when you convert it to meter per second, you will still get the same thing. So see, so what it means is that when you get, what it means is that on your graph, when you get let's say 25 centimeter per second square, in that place where you put that answer, after putting it, you will still show that your 25 centimeter that is up for your graph, for that place, is equal to 0.25 and it's a meter per second square. Hope it's not confusing. It's very confusing. See, this yellow 1.4 should be in our graph. This yes. See, on our graph, you will notice that our graph is 1/4 and this place is centimeter. Then this other side is seconds. Is it not true? Why, if you notice that thing that we did, the equations of that graph, we see that when we are dealing with that equation, that the L here will always be in meter and not in centimeter. So for that reason, it simply means that in that equation, because it's an equation and the SI unit of anything meter is anything length is actually meter, 10 over seconds. So what it means is that whatever I get in this equation, for it to be equal to what I have on my graph, I will have to say meter per second to centimeter per second square. Remember this one is second square, and this one is second square. So since I got on that equation, using that equation, I get 0.25. And when you divide this one, it will still give you 0.25 meter per second. So which means this is equal to this because that is what it is. Our slope is equal to this. So it's meter per second square. So what you have is converting meter per second to meter per second square to centimeter per second square. That will give you, then it is now, and you know that from meter to centimeter we do what? We multiply, shall we? 1 centimeter to meter, we do what? So it's not hard. So which means that for your graph, if you get 25, it is the same as saying 25 is in centimeter per second square. So when you're taking this to what we have here, it should be the same thing. And when you're taking what you have there to this, it should be the same thing. Just the limits. Yes. But please, when you are doing that on that question that they ask you, you will make sure that you are putting that question on that question. You are using meter per second square. So you need to show the test principle. However, you can express it. Now, in fact, when they say we should get the G, that's the standard error in G. Hopefully, the language. What do you know? Should I give you the formula? It's not hard. And some of you are there. So please, don't worry, I will do it and I will post on the group. Okay, you understand? Yes, that's our general group. So since 9 till 4 something, you have tried. But I believe we achieved what our goal today. So please, if you come back to go here, 1 year, this is where they present you academically. If you ever called you, please, if you're here, you are new, today is your first time. We did parasology this morning, before physics, then before this. So please, if today is your first time, take my number.
In Jesus' name, Heavenly Father, you are the creator of the whole universe. We appreciate you for the very beautiful class we have today. May your name be highly exalted in the mighty name of Jesus. As we are going, Lord,
Should we understand?
our destination in the mighty name of Jesus. Let the excellent spirit that rests upon Daniel rest upon us in the mighty name of Jesus. And at the end of the day, your name alone will be highly exalted in Jesus' name. For in Jesus' mighty name we pray. Now listen.